superposition principle in the case of waves first generally. So, and hence transverse progressive waves, and after that we will go through sound waves in the case of longitudinal waves example, and there also we need to discuss the same topic. Here principle of superposition of waves. A point on the string is taken. So a disturbance is created at this source, and if you say, so the wave transverse wave is generated and passing through this point. So you can take that this is the displacement of this point P when the first wave is passing through it. So here in this case, this y1 displacement can be taken as a function of x1 comma t, where this is at a distance of x1 from the source S1. So you can take that this is a function of x1 minus v1 into t. So that is the first function, like if you consider f. Similarly, if this point is a part of the second string also, that means two strings are not having knot at the point. This source yes, and it is also vibrating with some frequency. Then this is at a distance of x2 from this. Then this wave is also allowed to pass through this. If this displacement is taken as y2, so y2 is equals to some function of x2 comma time t, or simply f2 is equal f2 of x2 minus v2 into t. Like this, some set of waves are passing through it, like fn and xn minus vn into t. Then here, the displacement of this particular wave, this particular point, due to the influence of all the waves, will be the sum of the individual displacements caused by it, whether it is vector sum or simply algebraic sum. Suppose all these waves are passing through it. Of course, here transverse waves are passing through this particular point such a way the vibrations are caused in the same vertical plane. That means confined to same plane. Then they are said to be polarized. Vibrations are confined to same vertical plane. Then this is second wave, second one. Both are said to be polarized in the same vertical plane. Means it is a constraint vibration. It is. So here it is vibrating in the same plane. In such a case, algebraic addition of all the displacements simply gives resultant displacement. If they were not polarized in the same way, we need to sum up because the displacements will not be in the same vertical line, up and down or something like that. So we need to consider them in different way. We need to sum up vectorially. So here the resultant, y resultant is equals to sigma of yi, where I is running from 1 to n, or sigma of function n, x minus vt, as n value is running from, this I value is running from, we can take 1 to n. This is called principle of superposition. So let us take this example such that these two vibrations are in same vertical plane, these two vibrations are in, and both are superimposed. That means they are falling, passing through the same point. Then let us take y1 of x1 t is equals to, that is a sine kx minus omega t. Here we can take different amplitudes or we can take same amplitudes here. Just for simplification purpose, I am just taking both are having same amplitude from their mean position. Then y2 value is taken as x2 comma t. So it is a times sine of kx minus omega t plus phi. So another simplification made is x1 and x2 values were taken equal, same distance. That's why here also kx minus omega t, here also kx minus omega t. Then what is the phi value here introduced between these two waves on the chin? Here the phi is the phase difference between the two sources and the initial phase of phases of S1 and S2, whatever the small difference that exists. That means both may not be started simultaneously, or when one is vibrating such a way that it is crossing its mean position, but S2 is not in the same state of vibration, then you may say that there is some phase difference. That phase difference is introduced as a phi. Generally, we can derive just principle of superposition by taking A1, A2 different, A1, A2 different, and by considering phi, and X1, X2 different also. But the one important condition what we are considering here is that omega value is the same and they are passing through same type of mediums. Means here K value is also same we are considering. So here is a fundamental mode, it is not at a different cases we are just throwing our attention. Very fundamental. That means here omega is same means 2 pi into nu or f, where that means frequency of vibration f value is same for both the sources. So only difference what we are considering is there is some phase difference between those two. That's it. So how we will implement this sigma of this one? So in the case of two waves, principle of superposition states that y is equals to simply y1 plus y2. Correctly throwing it, x comma t is equals to y1 of x comma t plus y2 of x comma t. That means f1 of x minus vt plus f2 of x minus vt. This is what you call principle of superposition. So here the resultant wave due to superposition of those two, resultant wave due to superposition of the two waves passing through same point is given by simply here addition of these two sine of kx minus omega t plus a into sine of kx minus omega t plus phi, sum of these two. So now by taking here a common, sin c, sin d, like sin c plus sin d, that is 2 sine of sin c plus sin d, as you know, 2 sine of c plus d by 2 and cos of c minus d by 2. So here in this case c plus d by 2, it is kx minus omega t plus phi by 2 times, so here c plus d by 2 and then cos of c minus d by 2, either this way or this way you can take. So here you will get the value phi by 2. So even if you subtract, you will get minus cos of minus theta is same as cos theta. That's why here 2a cos phi by 2 is the term which is free from omega times sine of kx minus omega t plus phi by 2. So this is frequency term, this is free from that. So here in this case, this resultant one's another wave equation with frequency omega and with a phase difference of pi by 2 with the first one, that is the thing. And this term will indicate the amplitude of this new type of wave that has been exhibited here at this particular point due to superposition of those two. This amplitude, that a new value is equals to 2a cos phi by 2. So here in this case, depending on the phase difference between the two waves reaching to this particular point, here that amplitude, the way it is just vibrating, that is going to change depending on phi value, 2a cos phi by 2. If a1, a2 are different, this would be different. If a1, a2 are different, this would be another new value. Here in this case, superposition of two waves again results another wave here with a new amplitude of this, and here with a new same frequency of course, but with a phase difference of pi by 2 with the first one. So here in this case, to understand in a simplest way while doing some of the JEE problems, JEE means problems, here this displacement and this displacement, of course, in the diagram it seems to be some angle. No, it is purely illusion like, because this is sideways. Even though I am just trying to draw, the displacements what we consider are both are in the same vertical plane. That is the basic condition. Both are polarized along the same plane. Okay, both the transverse waves are polarized along the same plane. That means perpendicular to the direction of that, perpendicular to the direction of propagation of that wave, and the same vertical line. So here in this case, if you are trying to describe this, okay, this particular particle's displacement from the main position can be described by using this point P. This point P can be described by using a reference circle in the case of harmonic vibrations like. So here when it is having a displacement of y1, so this will be the kx minus omega t is the value of it. Theta is equals to kx minus omega t. So this is the phasor diagram, we will say, okay, generally. And through the second one, if you consider, that is simply the same amplitude. It is also A itself. So you can take the same kind of it, but it is of kx minus omega t plus phi. So this angle is phi. This is A. So corresponding to this and this, you will get the displacements y1 and y2. So now these two phasors can be added vectorially, which results 2a cos phi by 2, 2a cos phi by 2, which will be the resultant amplitude, and this angle is phi by 2, which is said to be the phase difference with the first one. Phase difference with first one. The same thing can be implemented in the case of A1, A2 different values, A1, A2. That means two different circles you will get. And you can extract it by doing the same, by applying simple vectors principle called parallelogram law of vectors. So it seems to be a vector obligation, but you must understand that this point is vibrating along the same vertical line. So addition of those displacements caused by the two waves separately is not vector addition. It is purely algebraic sum, because both the forces, of course, acting either in the same direction or in opposite sense. So you did it vectorially, the net force, and hence net displacement is to be studied. So it is not a vector addition of the displacement, simply y1 plus y2 or y1 minus y2. Now coming to this particular wave equation, whatever you got here, this amplitude 2a cos phi by 2 is the square of it. So just now we got intensity, we know that intensity expression, okay, it is involving amplitude, and the intensity is proportional to square of the amplitude. Square of the amplitude. Intensity is proportional to square of the amplitude. As you got, intensity is equals to half rho omega square. A square, of course, here it is nothing but average power transmitted per area of a cross section. So it is proportional to A square. Here we got, it is 2a cos phi by 2. So I is equals to some constant times, maybe like this, times a square, in this case the resultant is. So k into 4a square cos square phi by 2, cos square phi by 2. And here in this case, before superposition, whatever the intensity I naught you can take, which is equals to simply k square. So this I value becomes 4I naught cos square phi by 2 will be the intensity of it, resultant intensity. So here in this case, this intensity will be maximum, or its intensity may be minimum at different instants depending on the phi value. So here in this case, you will get I maximum condition and this I minimum condition. I maxima means this cos square phi by 2 value must be, maximum means 1, so that I maximum is equals to 4I0. So this phi value of it is equals to, sir, cos phi by 2, this one becomes plus or minus 1, and hence this phi value is equals to this value, cos value will be plus or minus 1 for all possible values of 0, pi, 2 pi, 3 pi and so on. So this value of phi will become 2n pi is the condition for it. So here in this case, for this value of the phase difference 2n pi, there here in this case intensity will be maximum, and such a type of superposition of waves is said to be constructive superposition. That means here the first wave which is reaching to this particular position of it, that if we consider this the thing, displacement on reaching to this point, the second one also will be reached in such a way that on to reaching to the same point. So this is what you call crest, this is also crest, crest falls on crest, resulting maximum amplitude like this, and hence intensity will be maximum. Crest falls on crest, or else you can say trough falls on trough like this. Then superposition caused by it is said to be constructive superposition. So I minimum value in the sense here cos square phi by 2 value should be taken 0, so that I minimum is equals to 0. So here cos square phi by 2 value is 0 in this sense. Phi by 2 is equals to 2n plus 1 into pi by 2. So on cancelling this, phi value is equals to 2n plus 1 into pi. So here in this case, this is what you call destructive superposition. Here it states. Here simply this is the point P plus the second wave is to be taken like this, the point P. So crest of the first wave falls on the trough of the second wave. Crest of the first wave falls on this trough of the second wave. That means they must have a phase difference of a pi like this. Okay, then you can say simply this one causes completely, this is equal means it becomes flattened, or if these two displacements are y1 and y2, if you take generally if you take different, then y2 minus y1 or y1 minus y2 will be the case. This will be y2 differ y1 like. This is called destructive superposition. So here the phase difference between the two waves on reaching to that particular point P will be a deciding factor, whether it is constructive superposition or destructive superposition. Maybe completely constructive sometimes, may not be. Different points will be at different cases. So in that textbook, NCERT textbook, you will come across such a type of beautiful pictures where different points are having different phase difference with which they are just superimposed, and hence at different levels it will be. So if you go through the textbook, you can come across such a type of a picture so that you can understand. So here they will ask you sometimes only phase difference is given to you. Yes, based on that you are saying constructive or destructive. Sometimes instead of giving phase difference, that initial phase difference means depending on the source's nature you may have some phase difference, as I told. Instead of having that initial phase difference, here if this is x1 and this is x2, here initially we assumed that x1 is equals to x2, so there is no phase difference because of this difference, this length travelled. Instead of that, I took it is the phase difference introduced between S1 and S2, the nature of that. But here in this case, let us consider these two are not having any initial phase difference, but lengths of them, that means the distance traveled by the wave to influence this point is different. Then here in this case, the initial phase of the first one will be k into x1 minus omega into t at any instant. Of course, it is one string, so it is taking some another influence like this. So at any instant of time t is equals 0, you can take r theta is equals to k into x2 minus omega t. So at t is equals 0, you are just observing it. That means at that instant. No, sir, it has taken some another time. Like that also we can consider. So my point is, there is no phi like that what we discussed. But here, this theta 1 diff or theta 2 will cause some phase difference phi, which is equals to k times of delta x, where delta x is nothing but x1 diff or x2. So this phase difference is equals to 2 pi by lambda times this path difference introduced. So phase difference by 2 pi is equals to path difference by lambda. So here you got phase difference is equals to 2n pi, means here path difference delta x will be equals to n lambda. Here path difference delta x will be equals to 2n plus 1 into lambda by 2 will be the case. So here I took 2n plus 1, here it is n. So n values what we have taken is 0, 1, 2, 3 and so on. Here also n value can be taken as same 0, 1, 2, 3 and so on. That's why I have taken it as 2n plus 1. If n value is taken as 1 onwards, so in some books it is given 2n minus 1, and some references it is given 2n plus 1 also. The way they have chosen n value. So this is briefly principle of superposition and the types of it and the conditions to have maxima and minima. That means constructive superposition and destructive superposition conditions, okay, were taken like this. So now this is generally wave analysis it is. Of course, I have taken transverse waves just for our consideration. This is a very, very important topic for us, which you will come across throughout the waves. That means not only in this, in the case of wave optics you will get similar type of analysis, you will get it in the case of alternating currents too. So understanding this one is very, very important. So here a brief recap of this. So two waves having same frequency, of course, propagating in the same direction, of course in the same region of space. If they superimpose on each other, then how the resultant one will influence medium particles. The resultant displacement of it is equals to, of the medium particles is equals to the algebraic sum of the two individual displacements caused by the two waves. So here in this case, to make it algebraic, we are considering that both the waves are plane polarized in the same vertical plane, and they are influencing this point at the same simultaneously. So then what we got, that y is equals to y1 plus y2, and we got an equation which is y is equals to resultant 1 2a cos phi by 2 times sine of kx minus omega t plus phi by 2, where phi is the phase difference between two waves. That's what we got. So it is again a new wave with the same frequency. It appears to be a new wave passing through those points, common points, with the same frequency f, but with a new amplitude 2a cos phi by 2. So based on that, the intensity of the resultant passing through those points is said to be equals to this much, and the intensity will be maximum for some conditions of phase difference and path difference, and it will be minimum for this. So for maxima, phase difference is 2n pi, for minima it is 2n plus 1 into pi. For maxima, condition for path difference is n lambda. For minima, condition for path difference is 2n plus 1 into lambda by 2. So maxima means it is what you call constructive superposition is taking place, where the intensity is minimum is passing through those points, means it is destructive superposition. In the case of sound waves, longitudinal waves like this, maxima minima appears in the case of intensity of sound. Thus, that is a audible sensation. In the case of light, this one will be visual sensation. So in the case of wave optics, you will come across alternative maxima and minima, so that we'll talk about alternative bright and dark spots on the screen, like, so it is a visual sensation we'll talk about. Whereas in the case of the longitudinal waves, means sound waves, the further topic what we had, there we'll talk about audible sensation of it. That means maximum sound, waxing of sound you will call, and waning of sound you will call. So here the maxima of intensity, minimum of intensity having different meanings. We need to perceive accordingly whatever the topic it is there. So this is the fundamental of superposition principle.